Welcome back to my channel, Statistics for Applied Linguistics. I'm Dr. Marnie Menegra, and in this video, we're going to look at post hoc tests for an ANOVA. Now, of course, what is a post hoc test? We're going to go live at the end of this video into JASP, so I can show you how to do this in JASP. And we're going to look at the Tukey test. There's a few different other post hoc tests you can use, but we're going to use the Tukey test in JASP today. And so the first question, what is a post hoc test? Well, a post hoc test helps you to determine which pairwise comparison of means contributes to the overall comparison of the F statistic. So since we have several different variables, sometimes several different groups within ANOVA, this shows you exactly where there is an interaction effect. So let's say if we had three different groups that we're comparing, and all three groups together, we have the results of the ANOVA are statistically significant. Well, maybe it's not significant between all three groups. Maybe it's just between two of the groups. So that will help us determine where the interaction effect is. And you're only going to do a post hoc test when the ANOVA is significant. So if you do the ANOVA and it is not significant, you can skip this step because the post hoc tests are also not going to be significant. We already know that. Okay, so for the post hoc test, it helps you to determine how the groups are different. And so what you're going to do is you're going to click on the post hoc test in JASP, click on Tukey, click on the confidence level at 95%, and move the language level over, depending on, this is for the one-way ANOVA that we're going to do. We're going to see live, you're going to see language level as a variable. And then you're going to analyze the results. If the confidence intervals cross 0, the groups do not differ. So how this will look for the one-way ANOVA, we've got three different language levels, A1.1, A1.2, and A2.1. So you click on post hoc test, you click on standard, you click on Tukey, you click on confidence interval at 95%. So here you can see on the right, the 95% confidence interval for mean difference. We've got a lower and an upper end. So here this crosses 0. This is not significant. But here we've got negative 44.233 and negative 6.367. This is significant. So if we go over to the right, you can see there's a T statistic and a P Tukey significance level. So this is less than 0.05 here as well. So the difference that we have is A1.1 to A2.1 is where we're finding that significant difference. We can even see how different they are on the plot diagram above. So this here is telling me that A1.2 has no significant difference between A1.1 and A2.1. It is only the two endpoints that are significantly different. Now, again here, the 95% confidence interval for mean difference, if the confidence intervals cross 0, the difference between the groups is not significant. Therefore, the significant difference is only between A1.1 and A2.1. A1.2 is neither significantly different from A1.1 or A2.1. And we can see that right here with these lines. So A1.1 and A2.1, this is where we're finding the difference. Okay, we can also do this with the repeated measures ANOVA. In a repeated measures ANOVA, you're going to come down, pull all of the variables over, click on confidence interval at 95%, do the Tukey test, and again, we're then going to look at this window here to see where there's a difference. So we have experimental pretest to experimental post-test. We can see there's a difference here, and experimental pretest to the control post-test. But for the pretest for the experimental group and the control group, there's no difference. And then if we look at the control pretest, we can see that to the control post-test, there's difference. an experimental post-test, the two different post-tests. These ones do not cross 0, so there's no significant difference here. We can also look at the P2 value over here and see which ones are significant. So this just gives us a visual as to where exactly there is a difference. And so here we can say that from pre-test to post-test, we've got a significant difference. But for the two different groups, the groups are not different. So we're going to go live into JASP right now, and we'll have a look at how that will work. And so I'm going to pull up first the one-way analysis of variance. And so here's the one-way analysis of variance. I've already got it loaded. We've got our descriptives up. We've got our effect size up here. We're going to scroll down to Post Hoc test. We're going to take the language level over. And we need to click on Tukey. This is going to be a standard. And we need to click on the confidence interval. So that's how we pull up the Post Hoc test. And this is the one that I was showing on the slides here, that if I zoom in here, we can see that the difference is between group 1 and group 3 only. There's no difference between group 1 and group 2, or group 2 and group 3, just group 1 and group 3. And so when we have the p-value is 0.009 and we have the effect size, well, this tells us where the interaction effect is, and it's only between the two groups, not between all three groups. So now let's look at, I'm going to stop sharing, we'll look at the repeated measures ANOVA. And for the repeated measures ANOVA, and I've already got everything loaded in JASP here. So on the repeated measures ANOVA, I've got an experimental pretest, experimental group post-test, control group pretest, and control group post-test. And there will be different videos showing how to do each of these ANOVAs, but this one's just on the Post Hoc test. I'm going to come down to this Post Hoc test here. We're going to take each of these groups, put them in, and click on the confidence interval at 95%. And then when I scroll down, you can see here between the lower and upper end, which ones do not cross 0. So the experimental pretest to the experimental post-test. So that is how you do the Post Hoc analyses in JASP for the analysis of variance. One thing to note, if you are doing a ANOVA does not allow for you to do a Post Hoc test. But with the other ANOVAs, you can do a Post Hoc test. So this brings us to the end of this video. Thank you so much for watching, and I look forward to seeing you in the next video.